Hello everyone, and welcome to another video of Coding with Jazz. And today we're going to be programming the algorithm to solve this cylinder puzzle. So as we discussed in the last video, we can represent the cylinder puzzle as a graph that looks like this. And then the question is to now solve this graph so that each row is made up of a single color. Okay, so I have implemented the framework from which we can program the algorithm that we came up with last time. So, yeah, we have the graph that we made last time, and with again the black node over here is representing the empty slot in the cylinder. And then we can also hit this randomize button to get a new puzzle to solve. And so the way I implemented this was using Pygame. And so Pygame is usually used for like arcade style games in Python, but it can also be used for other visual purposes like this one. And there's a little bit of a learning curve, but once you get to know it, it doesn't take too long to make stuff like this. So now looking at the code, our main program is this cylinder.py. Yeah, and I'll have all of this code linked in the description below. But yeah, so this is our main program, and it takes care of some of our basic like stuff, and it puts all of our different functions together in one place, and like yeah, runs the main stuff. So then we have the graph class. So a class is like it's a representation of something. So in this case, we're trying to represent a graph, and we have a bunch of data and functions associated with it. So like some of the data we need is the radius of one of the nodes, like how many pixels wide should a node be. The other things we have are the nodes. We need to like know where these nodes are, and so we have xy coordinates, and then we also have a color for that node. And then we have a similar thing for the edges. We have an xy coordinate for the left end and an xy coordinate for the right end. So this is kind of for drawing it to the screen, but we also need a representation for just between, like in the program itself. So we want to simplify things and say, okay, the edge, according to the program, the edge, all it really cares about is what is the first node and what is the second node, and the nodes will just be given a number from 0 through 20. So we have the 0th node, which is this one, and then we have the first node, and then the second node, the third node, fourth node, fifth node, sixth node, seventh node, and so on, like that. And then using that numbering, we can easily see like what we're looking at. Okay, so another piece of data that is stored in this graph class is the ball list. So it has a list of all of the different ball types that we'll have. So in this case, we have these 4 different balls and 5 balls of each color, and we're just going to represent them with a different number to simplify it. And then we also have a 0 for our empty slot, and then we can then to randomize this, all we have to do is this random.shuffle that will just shuffle our list, and then we read from that list in update graph over here, we just read that and we change our nodes accordingly, and um, then we have updated our, and then we have randomized our graph. Okay, so I've implemented the breadth-first search algorithm in the way that we discussed in the last video. So now it will fill in the blue nodes from left to right on the top row by moving this empty slot along to help the blue node get around, and then also using the breadth-first search to find the initial path that node should take. And also like which the nearest node is. Okay, and then I have attempted one method of solving the random, or solving the last two rows, and that is to do a random, just randomly move the balls around until we get to something close to a solution, and then solve it from there. But that doesn't work the best. Random movement, and we're trying to get towards a solution. And since we have only two rows, we would get to a solution eventually. The problem is just that it can take a while sometimes. Like we see it's been going for a while and it hasn't gotten there yet. But it is fairly close sometimes. So we need a different solution. Okay, so we need to create a new algorithm for the bottom two rows since our old one doesn't work. And what we can do is, well, we don't know like the exact path to the solution, but we can try and estimate how close we are to the solution by giving each puzzle state a score. And we can calculate the score by counting the longest like run of like a single color adjacent to each other. So like we have 3 adjacent reds, and then we can say we have 4 adjacent yellows. And then we're going to be moving this empty slot so that we can maximize the score, and then eventually we should get to the maximum possible score, which is having like all of the yellows next to each other and having all the reds next to each other, and then from which point it should be easy to get to a solution. And it looks like we're there. So we have these 5 yellows in a path. And so now if we just move them, if we just like rotate them into their proper row, then we should have a solution. And so we can do that just by sending this empty slot in a loop like this. And yeah, so you can see it shifted everything around, and now we're at the solution. Thanks for watching, and I hope you enjoyed this video. If you did, please leave a like, and if you have any questions, feel free to leave them in the comments below.